Welcome back. In the previous lecture, we have begin our discussion on power amplifiers. We saw that there are four important classes of power amplifier, the class A, B, AB and C. So these four class of power amplifier we will discuss. In this lecture, we will focus only on class A power amplifier. So the definition goes like this, that in the class A power amplifier, the biasing is always done to operate it in the linear region. So the characteristic of this power amplifier will be to operate it only in the linear region, with the output will be the amplified replica of the input. So whatever the input we are giving to the power amplifier, the output that we receive is basically just the replica of the input with certain amplification. Power amplifier deliver power rather than just the voltage to the load. So we are getting more power at the output of rated more than 1 watt. Obviously, if the power is more, then there will be some heat dissipation which need to be considered in this power amplifier. The heat dissipation in the power amplifier must be dissipated with the help of certain device. So the collector terminal is connected to the case of the heat transfer device. This is known as heat sink, which vary in size, material and design to manage proper the heat. High power application may require also the cooling fans. We have discussed in the previous lecture about the Q point operation in the power amplifier, that it should be in the center of the AC load line for the getting the maximum output signal. Q point location plays a very important role in the power amplifier operation. Q point, as it has to be located at the center of the load line with the characteristic of the collector current and collector to emitter voltage. So the collector current saturation or the quiescent point current, it varies from the saturation to 0. So we will be having the maximum collector current, which is the saturation current, and the minimum current we will be having the 0. So we can see this curve varies from 0 to maximum saturation current. On the other hand, the collector to emitter voltage varies from the cutoff to near 0. So here we can see this is the cutoff voltage of collector to emitter and this is the 0 point. So the collector to emitter voltage varies from 0 to collector to emitter saturation point or the cutoff point. We have also seen that there will be some clipping if the Q point moves away from the center. So the center point of operation of Q point, if it is moved up or down away from the center point, then will be certain clipping and you will not get the maximum power output signal. We have also discussed about the AC load line and DC load line in the previous lecture and saw that AC load line is steepest as compared to the DC load line. Let us derive some of the terms. What is power gain? So power gain is basically the ratio of the output power which is delivered to the load to the input power. So the output power by input power is basically the power gain. The load power can be evaluated using the expression load voltage square by the load resistance, whereas the input power is V input square by R input. So using this expression and substituting it in the main power expression, we get the power gain in terms of the voltage gain AV square multiplied with the ratio of the input resistance by load resistance. Let us take one example of common collector amplifier where the input resistance is 5 kilo ohm and the load resistor is 100 ohm. Let us take the voltage gain to be 1, then the power gain we can see it is coming to be 50. So this is a very high value of power gain. So the output power will be much high as compared to the input. The DC load line and the AC load line will also give the formula for DC power and AC power. So the power of DC condition in the quiescent point is the product of the collector current and collector to emitter voltage at the quiescent point. So the interpretation goes like this, that this represents the power which is dissipated with no input signal. So without having any input signal, what is the power which is dissipated? The transistor must be rated for power exceeding this value. So in order to safely operate the transistor, the rating of the transistor must be greater than the value which is the power dissipated by this equation. When we talk about the output power, so we saw that the transistor has to operate at the center of the Q point. So the maximum peak output voltage swing then in that case will be equal to the collector current saturation multiplied with the resistor of the collector. RMS value, if we want to calculate, then root 2 we have to multiply it, which is 0.707 multiplied with the value that we got for the maximum. Maximum peak current swing, if you want to find out, then that is equal to collector to emitter voltage divided by resistor of the collector at the Q point. And again, the RMS value is 0.707 times the maximum. Maximum power output in that case can be put in this equation. We get 0.5 collector current multiplied with collector to emitter voltage. So the efficiency is basically the power output by the DC power, and the DC power is equal to the collector current multiplied with collector voltage. So we saw that it comes to be 2 ICQ BCQ from the previous expression. Hence, the efficiency for capacitively coupled class A power amplifier comes to be 25%. Typical efficiency generally is about 10%, but this is the maximum efficiency of 25%. So transformer coupling will improve the efficiency but has certain drawback like size, cost, and potential distortion. Hence, we have seen here that the maximum efficiency of the class A amplifier is 25%, and if instead of capacitively coupled amplifier, if you put transformer coupling, then certain drawbacks we can obtain in terms of size, cost, and potential distribution. So this was the second part of power amplifier where we discussed about class A. The other classes B, A, B, and C we will discuss in the coming lecture. Thank you for now.